Hi, and welcome back to Element 14 Presents. I'm Natasha, and in this video, I'll show you how I made these NeoPixel Mickey ear hats using the neon type NeoPixel strip. I used microbit for this project, and that was key because I could use the radio on board to make multiple hats for my friends. I customized the animations to match the attractions that we were going to, and we wore them throughout the park. Let me show you how I made it. For this project, I chose microbit because it has these really easy to connect pins, onboard buttons, and also a really reliable radio, and that'll make it easy for me to connect the hats together. It's also really easy to program, so I feel like anyone can do this and bring it to the park. So here's how it'll work. The pair of mouse ears will show one of the 9 animations that I created that'll match different themes across the park. And I can use the buttons on the microbit to toggle through the modes and change the different animations. But the really cool part is that when I toggle through my animations, I use the microbit radio to broadcast the mode to the other microbits around me. And that means that all of my friends' hats will change color at the same time, giving us a cohesive look and making everyone in the park know that we're all one group and traveling together. In addition to the microbit, I'm using a 2 AAA battery pack with a switch. I highly recommend getting one with a switch so that you can easily turn these on and off as you're going in areas of the park that might not allow you to have some lights on your head. Using these side light neon style NeoPixel strips. I have some 3-wire ribbon cable that'll make the NeoPixel strips easy to connect and solder. To connect the NeoPixels to the microbit, I'm going to use these screws. Instead of using an edge connector, this is a really quick and simple and cheap way to make a simple microbit project and still be able to remove the connection when I want to use the microbit for a different project and then replace it when I want to use it for this project again. I found this nice simple black hat to use as my base. I looked for one that doesn't have the foam on the inside so that it's just fabric and easy to work with. And then I have some 6mm black cosplay foam to create the ears out of. I have some glitter paper to make it shiny and a little bit more fancy, and a piece of felt to add some finishing touches at the end. The circuit for this project is extremely simple. It will be 2 NeoPixel strips that I'll cut out of this bigger piece, connected with some 3-wire ribbon cable, and then connected to the microbit with the same 3-wire ribbon cable. And then it'll just be a battery pack to connect for power. That's pretty much it. Everything else will be building the hat and playing around with the animations and the colors in the code. I designed the ears ahead of time in Illustrator. These files are available for download on the Element 14 community, so go check that out. I'll start by cutting these out. So I'll trace these patterns onto my foam with this Sharpie marker. And for this piece, I'll trace one of them facing this direction and then flip the paper over and trace the other one facing this direction. And then I'll just use an X-Acto blade to cut all of these out. I want to use my blade straight up and down. I don't want to give it any type of angle when I'm cutting this so that the edges will be nice and flat. I'm going to cut out these little rectangles as accurately as possible because the little ears are going to stick through this. This part doesn't have to be pretty, but it does have to be accurate so that the earpiece will fit inside of it. Okay, so those are our foam pieces. This battery cable is going to go into the hat and back out of the hat on the other side. So actually the microbit is going to have its battery holder facing down and the wire is going to have the wire facing down so that the two can meet easily inside the hat. It doesn't cover the battery holder because I don't want the Velcro to go over the battery holder. Actually, maybe we'll go with pin 1 so I can use this for the Velcro. Okay. I can use pin 0 instead, 3-volt and ground. Okay, I can cut this a little bit off. Nice sturdy spot for my microbit. Put some Velcro through this one too. So something like this. Okay, So now I will cover the front side with some glitter paper using the other piece of the template, and that will cover up the front of this Velcro here. This is the same as the other one. I'm going to trace one on one side and then flip it over and trace it again on the other side so that I have one in each direction. Two glittery pieces of paper, and these will get glued right here, and I'll just throw a dab of hot glue to put them in place. For the hat, I want to put the ears just slightly behind these little holes because that'll prop it up kind of on top of my head. So what I'm going to do is kind of turn it inside out here, and I'm going to place this piece, which is going to go on the inside, kind of just on top of where those holes will be. Yeah, like that. And I'm going to mark where I should put the cut in the hat, so it's not bad. Hat holes. And now if I put this inside here, theoretically should be able to put this through the hole and pull it through the little tab on the inside here. There we go. So we have a little ear. Bum-ba-da-da. You know, come to think of it, this would be just a cool way to make ears that don't even light up. Just make some regular Mickey ears like this. This will, oops, needs a little glue. Okay, so I'm gonna add some glue to that now that I know that it works. Okay, time for LEDs. I've cut back some of the casing, and you can see that there are little tiny NeoPixels facing sideways, and they only can be cut every 3 pixels. So I'm trying to plan for that distance around the ear. I think it's going to be 6 sets of 3, but let's test that out. I'm going to go with 7 to start with. Be something like that. Ooh, maybe I should have gone with 8, 7, 8. Oof, here we go. All right, right through the copper pads. Look at that, perfect. 8 of these bad boys. I found just the tiniest bit of heat shrink here in my bin of heat shrink, and it fits just fits over this. So I'm gonna thread these on first and see if this helps me later in reinforcing this joint. It might not. It's kind of short, and I actually only have 2 little pieces of it, so actually 3 little pieces, but one's way too small. So hopefully these will end up being handy and help me out, and if not, then I just put an extra piece of heat shrink on something, no biggie. I've taken a longer piece of ribbon cable than I maybe needed, just putting holes where those other 2 holes were. And I'm gonna actually solder the 2 LED strips together while they're kind of connected to the hat, but give myself some slack so I don't have to actually get the soldering iron like right up against the fabric of the hat. Just got stuck on a little piece of glue. No, Mr. Glue. No. Okay, there we go. Okay, something like this, and then eventually, once I solder them and put everything into place, I'm gonna pull this inside the hat again, down, and then this I'll have to like flatten or something and just kind of cable manage it inside the hat. But I think that's better than trying to cut it to the correct length to solder right here in this joint because it's so tiny there. So I'm giving myself some slack. I'm gonna solder the 2 LED strips here and then go from there. So I broke this one open, and I can see now that the data is going in this direction. So I kind of have to look at it and try to figure out which side to connect all of these things to. So if I make this one the same and I flip it around, I want the microbit to connect to this end, connect to the wire, and then connect to the wire, and then go around. So it'll be basically one continuous strip around these. So I'm going to solder this wire to this side, and theoretically then, if I look at my other one here, yes, the data is going away from the microcontroller. Okay, wish me luck. Inside here, I added some bit of solder, and then I pre-tinned these guys here. This is ugly, but it is technically connected, so I'm going to go with ugly over perfect because I do not want it to break. and I don't think it will give me a second chance. Now that I have these 3 solder points connected, I want to test it and add some code instead of finishing the build and then finding out that one of these connections doesn't work.
Do you like winning free stuff? Are you an electronics hobbyist? Do you like building cool projects and winning prizes for what you build? The Element 14 community presents Project 14, the member-driven destination where you decide on the challenge. You enter projects to win monthly prizes and you vote on the winners. What are you waiting for? Join the Element 14 community so you too can enter one of our contests or submit an idea for your own. Join now!
The code for this project comes in 2 parts. We decided that we were going to use a controller to control everyone's hat instead of having to use one of the microbits that was on our head to control everyone's hat. That way we didn't have to touch our hat all the time to make the animations change. So we went with one controller that we can change the mode with and keep this in our pocket. We uploaded the same code to each of our 4 hats, but there was one animation where we chose our own color, so we changed that color variable each time we uploaded, so we each had our own main color for one of the animations. You're probably wondering why the LEDs are so dim. That's for 2 reasons. One is we wanted to conserve battery power throughout the day, so it would last longer. And 2, because when you're in a queue for a ride, it's actually quite dark. So having super bright LEDs would actually blind us and other people, and we didn't want them to hate us. So we made sure that the LEDs were quite low in intensity, but once you get into the queue, they're very, very visible. The controller code is quite simple. It just increases the mode every time you hit B and decreases the mode every time you hit A, and then sends that out over the radio to be received by the others. The code on the hats receives the mode and then plays one of the 11 animations that we came up with. That was just how many we had. This is the code for the controller microbit. It's fairly simple. We just start by setting up the radio group so that we have them all communicating on the same channel. We set a current mode and we told it how many modes we had created. If you press button A because it's on the left, it goes down in mode. And if you press button B, it goes up in mode. So we have a down and an up button. If it gets any larger than 11, it starts over at 1. And then in our forever loop, we just have the current mode showing on the little display on the front of the microbit, and it's sending whatever mode we're on out to the other microbits in the area. So it's just pick a mode, send it. That's all. So now let's check out the code for the individual hats. So we start out by setting up a NeoPixel strip on our pin 0, which was over there on the left, and we tell it how many NeoPixel pixels we have. In my case, it was 48. It might be more or less depending on your size of ears and what format they're in. Then we have 2 other strips that I created, one that is the left ear and one that is the right ear. That was helpful for me to create different animations. That's kind of an optional step. If you wanted to do everything where all of the pixels were doing the same thing, you might be able to skip it. It's also important to set our radio group. We used group 1, but you might want to change that depending on if there's other microbit users in your area. And we have just some starting, setting the current mode to 1 and the number of modes. Oh, in our case, we want it to be 11. So let me change that. Okay, so we have our radio received block. So this is now just listening for the controller to tell it what mode to be. So if the name is mode and it comes in, it's going to set the current mode to whatever value that is. And now we have a forever loop, which is just checking to see what the current mode is and then doing different stuff depending on what it is. So this was just a really fun thing. I went in and I decided to come up with all different types of animations. In this case, this one, let's see, is blue sparkle. So it's blue and then it randomly shows a white pixel. So it's blue and it goes like glittery white all over. I have, let's see, another one that just shows rainbow. Who doesn't love a rainbow? Okay, and then after all of that, so you can experiment and make your own function for each mode and then, just try out different stuff. And then the last thing that I did was I added on each individual ear the ability to change the mode as well. So if you were traveling apart from the person who had the controller, you could also manually change the mode on your ears if you wanted to. And then remember, we use the battery pack with the on-off switch, so if you do need to turn the whole thing off real quick, you can just reach up and kill the power on it. So that's the code. This code is available to download on the Element 14 website, so you can play around and take a look at how you might add to it. Also, it would be really fun if you create something to post it as well, so we can all share Mickey ear animations. That would be really fun. So my plan is to strip this slightly, and this is so that I'll have a little handle to wrap around the screw that's connected to the microbit, like that. So I'm leaving these screws just a hair untwisted, and this way I can twist my wires around. Okay, moment of truth, going to plug this in. Okay, turn it on. Something, yay! Do I have some type of tilt sensor on this? Oh, that's what this code does. I put the wrong code. Look, if I tilt it, it goes green, and then it goes red, and then it goes green, and then it goes red. This is because we were thinking about this idea that if you tilt your head, it goes one color, and when you're standing up straight, it goes another color. But this is the wrong code. But hey, look at this example of a cool thing that you can do with the microbit. If you're too close to the edge, look, it flashes. Okay, different code. Coming back. Now I have the actual code on it and a real moment of truth. Yay! Lights. So now I need to attach the lights to the foam and get them to stay in place. Now, these are silicone covers, so nothing's going to stick to this. So what I'm going to do is use some straight pins from my sewing kit to stick through the silicone and through the foam on the ear, and that way it'll be a mechanical connection instead of a glue connection, because I don't want to have to deal with stinky glues that probably won't work. I'm going to go very close to the edge, and I'm going to align it to the back of the ear like this. Alright. That looks pretty good. I just got back from resoldering this connection here. Admittedly, this is quite the fragile connection, but I'm hoping once I kind of stick it in here and it's all cradled in the fabric and the foam and everything, it will not come undone. Ha! Let's hope! Let's hope! If I was someone who was not me, I would probably stop here, but I do like having this look a little bit more finished, so I'll add a bit of felt and some edging using the glitter paper that I used for the inside. There's a tip. Put the battery pack with the on-off switch facing out so that you can turn it off and on. Okay, so this is going to look awesome in the dark. If I were to change one thing about doing this project, what I totally would have done is used my X-Acto blade to remove the covering from the neon NeoPixels, soldered them outside of their covers, and then replaced it. Because I was putting something on the back anyway, you never would have known that there was a seam on the back, and it would have made the soldering so much easier. I was like sticking the soldering iron into the most impossibly tiny little spot where I could have had all of the room in the world otherwise. So I would highly recommend doing that if you're going to follow this project. It will make your life easier. Other than that, I'm really happy with this project. It was so fun to walk around Disneyland, and so many people gave us compliments, so that was really fun. And I hope that you will make this project with the template and the code that we've put on the website. And if you do, have fun at Disneyland. I'll see you next time.